Good day everyone. In the last video, we saw model 1 about continuity, right? That is finding the value of the constant k. Today we are going to see about the continuity and discontinuity of certain functions. For doing the MCQs, you need to know the concepts very well. That is very important. Okay. So now let me tell you some general concepts about continuity and discontinuity about certain functions. Right. Now first let me tell you what are all the functions which are continuous everywhere. Okay. So polynomial functions. You know what is a polynomial, right? Like a cubic function and a quadratic function and a fourth degree function. Like in algebra you have so many functions, right? They are all polynomials. And a constant function, that is your f of x, will be equal to some constant. Identity function, that is your f of x, will be equal to x. Then exponential function, in this you can include a power x as well as e power x. Then modulus functions, all these functions are continuous everywhere. Okay, this is one main concept. Then in the trigonometric function, that is there are 6 trigonometric functions, isn't it? Sine function, cosine function, tangent function, cotangent function, secant function and cosecant function. In that sine function and cosine function, they are everywhere continuous. Now let us deal about the other 4 trigonometric functions and inverse trigonometric functions, logarithmic functions. These are all continuous in their domain only. Now I will explain what is the domain and where they are continuous and where they are discontinuous. Before going into that, I want to tell one more concept, that is, if you have two functions f and g, that is f of x and g of x, okay, which are continuous, then you can say f plus g is continuous. Similarly, f minus g, that will also be continuous, and f into g, that will be continuous. Okay, is it clear? If you have two different functions f of x and g of x which are continuous, then the sum of the two functions, the difference of the two functions, the product of the two functions are continuous. But when you take f by g, that is the quotient, f of x by g of x, in that case this will be continuous in all the cases except, that is, if your g of x becomes 0, it will not be continuous. Or I can add a condition, g of x not equal to 0, then only the f by g will be continuous. Okay. Then if you can even take like g by f or 1 by f, these will be continuous only when your f of x is not equal to 0. So is it clear? So now these are the concepts first I have told. Then I will explain to you regarding the domain of the 4 trigonometric functions, then inverse trigonometry and logarithmic. Because if you know these only, certain MCQs you will be able to answer easily. Okay. Now already I told you sin x and cos x are everywhere continuous. Okay. Now tan x and secant x are continuous in or minus 2n plus 1 pi by 2 where n belongs to z. Let me explain the reason. See, tan x is nothing but sin x by cos x. Secant x is 1 by cos x. In both these functions, cos x is in the denominator. I told you, if it is of the form f of x by g of x, then the g of x should not be 0. You know, cos x will become 0 for all odd multiples of pi by 2. What is the generalized form of an odd multiple? That is no pi by 2, 3 pi by 2, 5 pi by 2, or it may be minus 3 pi by 2, etc. That generalized form is 2n plus 1 into pi by 2. This is the generalized odd number. N belongs to z. So, except these, in all the things, tan x and secant x will be continuous. Is it clear? So if they ask you tan x and secant x discontinuous, means you will just write 2n plus 1 into pi by 2, n belongs to z. If they ask you about continuity, it is r minus 2n plus 1 into pi by 2. See the question properly, read it and then answer. Then coming to cot x and cosecant x, you know this is cos x by sin x. This is 1 by sin x. So the sin x is in the denominator. Sin x will become 0 for all multiples of pi. Isn't it? 0, pi, 2 pi, 3 pi, etc. So it will be continuous in r minus n pi, n belongs to z. Right? So cot x and cosecant x will be discontinuous in n pi, n belongs to z. Hope all these things are clear to you. You have to note down all these things so that you will remember at the time of the examination. Now let us move on to inverse trigonometric function. Actually in the chapter 2 where you have the inverse trig functions, they have given the domain and range of all the inverse trig functions. From that you have to club like this. For sin inverse x and cos inverse x, they will be continuous in minus 1 to 1 close bracket. Tan inverse x and cot inverse x will be continuous in R, that is all real numbers. Secant inverse x and cosecant inverse x will be continuous in minus infinity minus 1 union 1 to infinity. Always note infinity whenever it comes, it will be a open bracket, and for this number it is a closed bracket. So now you know regarding all the trigonometric functions and regarding all the inverse trigonometric functions, where they will be continuous and where they will be discontinuous. Now just few more concepts I have to tell you regarding some other functions, right? This is called greatest integer function x. Okay, this function is discontinuous at all integral values of x. That means for 1, 2, 3, minus 1, minus 2, minus 3, like that. For all integral values of x, this will be discontinuous. Okay. Then, when you consider the logarithmic function, it will be continuous on 0 to infinity. 0 not included, and this is also a open bracket. So, you should remember this. When your f of x is within square root, maybe it is x minus 4, x minus 2, whatever it is. Whatever is there within square root, that should be greater than or equal to 0, because if you have a negative within square root, then there won't be any real number answer, isn't it? So you should equate whatever is inside to greater than or equal to 0. So x greater than or equal to 4. So this will be continuous in 4 to infinity. Okay, have you understood this? Greatest integer function, logarithmic function, and if your f of x is within square root, right? Now I told you a modulus function is continuous everywhere. But you look at these three things. Mod x minus 4, it is a simple modulus function. Definitely it is continuous everywhere. Okay. But you look at the next. Mod x minus 4 by x minus 4. X minus 4 by mod x minus 4. Now these two functions are like f of x by g of x, two things, isn't it? So the f of x is continuous, g of x is continuous, that is correct. But there is one condition, you remember, g of x not equal to 0. So for these two functions, x should not be equal to 4, or I can say they will be discontinuous at x is equal to 4. So you should know the difference between a simple modulus function and like this f of x by g of x format. So here these two are discontinuous at x is equal to 4, and this is continuous everywhere, right? Now in general, what are all the cases in which you will call a function discontinuous? Case 1 is if your f of x is not defined, then you can say the function is discontinuous. Okay. Second, if the left side limit not equal to right hand side limit, that means the f of x limit x tending to one particular point will not exist in that case. So when LHL not equal to RHL, the function is discontinuous. The third case, your LHL may be equal to RHL, but it is not equal to f of a. Then the function is discontinuous at the point a. So this is in general summing of what are all the possibilities of discontinuity of a function. So if you are clear about all these concepts I have now discussed, it will be very easy for you. Now let me do one or two MCQs based on these concepts. Okay. Now let us see this sum. F of x is equal to mod x plus mod x by x is continuous at origin, discontinuous at origin, since mod x is discontinuous at x is equal to 0. Discontinuous at origin since mod x by x is discontinuous at x is equal to 0. Discontinuous at x is equal to 0 since both mod x and mod x by x are discontinuous at x is equal to 0. Now, if you remember the concept I have explained, you can yourself choose the correct option. Now, this is a simple modulus function. Definitely this is continuous everywhere. Now see this term. This is like f of x by g of x. You know, when it is like that, the g of x not equal to 0. So x should not be equal to 0. So this function will be discontinuous at x is equal to 0, right? So which option is correct now? The option C, because it is discontinuous at origin since mod x by x is discontinuous at x is equal to 0. Because this is continuous, only because of this it is discontinuous at the origin. Is it clear now? I think if you know the concept, is it not easy? Right. Now let us move on to this sum. F of x is equal to mod x plus mod x minus 1 is continuous at both x is equal to 0 and x is equal to 1. Continuous at x is equal to 0 but not at x is equal to 1. Discontinuous at both x is equal to 0 and x is equal to 1. Continuous at x is equal to 1 but not at x is equal to 0. Right? Now, this is a modulus function, continuous everywhere. This is a modulus function, continuous everywhere. And there is a plus sign. So, if f and g are continuous, you know f plus g is continuous. So, definitely this is option A, continuous at both x is equal to 0 and x is equal to 1. Okay, so the concepts, please read it again and again and register it in your mind. Definitely you will be able to answer these sums, right? Now, let me tell you few concepts about differentiability. Okay, a function f of x is said to be differentiable at a point x is equal to a if the left hand derivative is equal to the right hand derivative. How do we find the left hand derivative? It is limit extending to a minus f of x minus f of a by x minus a. Right hand derivative is limit extending to a plus f of x minus f of a by x minus a. F of x may differ for the left side as well as the right side. So automatically the f of a will also differ. We have to find both the derivatives, and if they are equal, then the function is said to be differentiable at that particular point. When is a function not differentiable? There are three cases you should know. First of all, the basic condition is if a function is continuous only, it is differentiable. Okay? That means if it is discontinuous, it is not differentiable. But if it is continuous, that does not mean it is differentiable. It may be differentiable, it may not be differentiable. Is it clear? So, if a function is discontinuous, it is not differentiable. If a function is continuous, it may be differentiable, it may not be differentiable. Okay? Then, second point. If there is a vertical tangent as a particular point, then the function is not differentiable at that particular point. Third case, if there is a sharp turn in f of x, then the function is not differentiable. For this, the best example is a modulus function. You know, any modulus function will be like a V graph, isn't it? So it will be at this point. So there will be a sharp turn here. So the modulus functions will not be differentiable at those points. Let me give you an example. If you have your f of x is equal to mod x plus 2. Here you equate this x plus 2 is equal to 0, you get x is equal to minus 2. That means this mod graph here is minus 2, so it will be like this. Your mod graph will go like this. At this point minus 2, it will take a sharp turn. So this will not be differentiable at x is equal to minus 2. So a modulus function is continuous everywhere, but it is not differentiable at the point where it takes the sharp turn. That is, if you equate what is within the modulus to 0, that x value, at that point it is not differentiable. If you take f of x is equal to mod x minus 4, it will not be differentiable at x is equal to 4. Is it clear? So now let us do one or two sums which consists of both continuity and differentiability together, right? F of x is equal to mod 2x plus 3. Then f of x is discontinuous at x is equal to minus 3 by 2, continuous and differentiable, discontinuous and non-differentiable, continuous but not differentiable. Okay. Now let us analyze properly. First, a modulus function, it is continuous everywhere, correct? Then a modulus function is not differentiable at the point where it takes short turn. How will we find that? We will equate what is inside is equal to 0. When you equate 2x plus 3 is 0, 2x is minus 3 and x becomes minus 3 by 2. So it is not differentiable at x is equal to minus 3 by 2. So now let us tick the option D, continuous, okay, but not differentiable at x is equal to minus 3 by 2. Is it clear? Let us move on to the fourth one. F of x is equal to x by 1 plus mod x. The set of points at which f of x is differentiable is, they have given you the 4 options. Here, this modulus function, if it is the only one in the denominator, we know it is not differentiable at x is equal to 0. But here it is 1 plus mod x. So it is different. It is not just a modulus function. So let me find the left hand derivative as well as the right hand derivative for that. For that, you should know the 2 interpretations of any modulus function. So mod x is equal to x when x is greater than or equal to 0. Mod x is equal to minus x when x is lesser than 0, right? This is how you have to interpret a mod function. So when I consider my LHD, my f of x will be when x is lesser than 0. So my mod x will become minus x. So I will get x by 1 minus x, correct? So now let me find the LHD, that is f of x minus f of a by x minus a, x tending to a. A is 0 here. So I will write limit x tending to 0 minus, I will get x by 1 minus x minus f of a. Put x is equal to 0. 0 by 1 minus 0. So I will get 0 by x minus a. So x minus 0, correct? So that will be equal to, I will get x by 1 minus x into 1 by x. This x and that x will go, limit x tending to 0 minus. So when you put x is equal to 0, 1 by 1, so your LHD, the answer is 1. Is it clear? Now let me come to my RHD. In my RHD, I know my x is greater than 0, right? So the f of x will become x by 1 plus x. So here the f of x is now x by 1 plus x. Now let us do limit x tending to 0 plus. In the place of f of x, you write x by 1 plus x minus f of a. Substitute x is equal to 0. So you will get 0 by x minus a, x minus 0. So you will get x by 1 plus x into 1 by x, limit x tending to 0 plus. This will go. Substitute x is equal to 0. You get 1 by 1. So this is also 1. So the left hand derivative and the right hand derivative is equal to 1. Now, why I particularly chose that 0? Because of this mod x, no? I have chosen that 0. because in all other points, the function x by 1 minus x as well as x by 1 plus x, they will be differentiable, I know. So now it is differentiable at x is equal to 0 also. That means it is differentiable at all the points. So the option C, that is minus infinity to infinity, will be the correct option. Because of mod x, no, you may think it is not differentiable at 0, but because of that 1 plus mod x, it is a bit different. So hope you have understood all the concepts and the examples I have explained. So let us finish this continuity and differentiability. We will do the differentiation sums in the next video. If you have any doubts in any particular sum, you can please write it in the comment section, or you can contact me in my WhatsApp number 98414-24159. Definitely I will help you and clear any of your doubts. Thanks for watching the video. If you like it, you can share it with your friends. Thank you once again.